Welcome to Solving Problems with Similarity and Congruence podcast. So we're going to be solving some of the problems in your notes. So you're going to need your note template. If you don't have your note template, pause the tape, go get it, and come right back. This problem we had done in class. Fifth period had finished. Third period was almost finished. So I want to just go over it. So to find missing sides in similar triangles, we can use proportions. To solve proportions, we can rewrite the proportion as an equation using cross multiplication. So in the diagram here, we have triangle BCD, similar to triangle RST. Because they're similar, the corresponding side lengths have to be in proportion to one another. Well, if you're in proportion, that means we can use a proportion to solve for a missing side. And actually, we're going to be using proportions to solve all of the problems involving similarity. We have a couple congruence problems in here. We won't be using proportions for those. But all the ones involving similarity, absolutely, we'll be using proportions. So here we set up our corresponding parts. When you set up your proportion, make sure you have one triangle in the numerator, one triangle in the denominator. It'll just make it much easier for you, because it's very important. This only works if we have a common thread in the numerator, a common thread in the denominator, and a common thread in each fraction. So here our common thread in the numerator is that both RS and RT are sides in triangle RST. Our common thread in the denominator are that both BC and BD are sides in triangle BCD. Our common thread in the first fraction is that RS corresponds with BC. So if we look at the triangles here, RS, well, if I have a line, RS corresponds with BC. What if you're not sure how it matches up on the triangles? You can't tell which one goes with which. If you have a similarity statement, you can use your similarity statement, and that's probably the easiest. Here, they're situated the same way. The sides that go together on the bottom or on the right or on the left. But sometimes it's not so easy. So you can just use your similarity statement. So BC goes with RS. Those are the first two letters. And in the second ratio, we have two other sides. RT goes with BD. Okay? Here we knew all three sides in triangle BCD and two of the sides in triangle RST. We didn't have to use BD and RT. We could have used CD and ST. Okay? But they do have to correspond. So if I used BD and ST, I would have a problem because I'd get an answer, but it wouldn't be right. Okay? And so now we replace those the words, the segments with the values that represent each of those. So RS we replaced with an X, and BC with a 13, and RT with a 10, and BD with a 5. We could reduce the 10 and 5. Okay, so 5 goes into 5 one time, and 5 goes into 10 two times. And then we cross multiply. A cross from catty corner, from diagonal, right? So from the left corner, the upper left to the lower right, and the upper right to the lower left. Because there's a property that cross products, I have it written there, cross products of true ratios are congruent. So the cross product 5x has to be, or in this case 1x because we reduced, has to be congruent to the cross product 2 times 13. Okay? And then all we have to do now is solve for x, so x is 26. Okay? And I'll also show you how you can check your work. When you reduce, make sure you only reduce within a fraction or within a numerator and denominator. Do not cross-reduce, or you change one cross product without changing the other. Right? Because if I change the 10 and the 13, I'm changing one product, because I'm going to multiply those two, and I didn't change the other. So how you can check your work? Well, let's just plug it in and make sure that it's still in proportion. So here I'm gonna do a little check over here. So if I put the sides together, right? So RS goes with BC, and RS is when we solve for, that's 26, and BC is 13. And RT goes with BD, so RT is 10, and BD is 5. And ST goes with CD, so ST is 24, and CD is 12. Now notice I have all of triangle RST in the numerator, and I have all of triangle BCD in the denominator. I can't go mixing up the triangles, otherwise it's not going to work out. And if I reduce all of those, well, 26 over 13, that's 2. And 10 over 5 is 2. And 24 over 12 is 2. So that checks out. So if I had made a mistake, when I went to plug it back in and check it, I'd get a crazy ratio. It wouldn't match the other two. Okay? So that's how you can check your work. So I recommend you check it on quizzes and tests and benchmarks. I'm going to check it here just so you can see, yep, that's the right answer. So I'm going to do a few of the problems in your notes, and so you'll take notes as we go along. All of them will be missing sides and triangles. All of the applied problems we'll do in class. This one is actually a pretty tricky problem. These are similar triangles. We had seen some similar problems, like similar triangles to this, on the similarity podcast, if you've watched that one first, where you had to determine which was the correct postulate. Okay, so these are two similar triangles. We see we have the parallel lines, so our corresponding angles are congruent. They also share this one. Very important when you set this up is to match up corresponding parts. Okay? If you don't match up corresponding parts, it won't work out very well to you. So don't match AE with ED. They're not similar. Okay? The triangle is not similar to the trapezoid. It's AE with ED, the whole side. If you have trouble, draw your triangles out separately. Oh, that's a terrible looking triangle, isn't it? Let's try to make it just a little bit better. Well, it's just a little bit better, but it's good enough. All right, so we have A, E, B, and AE is 6, and EB is 5. And then we have the larger, let's see how this one comes out when I try to draw it. Well, I'm going to run out of space, so it's going to come out terrible. But that's close enough. And we got most of the triangle in there. There we go. And the larger A, DM. And AD is not 9, not 6, but 9 plus 6. Right? So this is 9 plus 6, which is 15. Right? And then DM is x minus 3. So we're going to solve for x here. And so we want to write it in words first. Right? So EB, actually let's put DM first, because we want to make sure we use that one, because that's the that happens to be what we're looking for. We're looking for that x that's in DM. Right? So I'm only going to use the big triangle in the numerator, and that would be triangle ADM. And then I'm going to use the smaller triangle AEB in the numerator. And I have to make sure I match it up. So DM goes with EB. Okay? I guess you'd call it the bottoms of the triangles. So these two go together. These go together. Okay? And then AE goes with AD. Right, so now I'm going to match up these two. And I have to put the big triangle in the numerator because that's the one that's in the numerator now. So I have to put AD in the numerator. And I have to put AE in the denominator. Okay. And now we'll plug in the values. So DM is x minus 3. EB is 5. AD is 6 plus 9. Remember, it's 15. And AE is 5. Okay. And you can reduce here. I think I'm going to reduce the 5 and the 15. I cannot, not no way, no how reduce these two here. I cannot reduce the 5 and the 15 because otherwise I'm going to affect one product. I'm going to have a 3 over here and I didn't do nothing to the 5 times x minus 3. So that would be wrong, wrong, all kinds of wrong. Now I'm going to get rid of those boxes. I don't want to give you any ideas. Don't cross reduce. We can reduce within the fraction. And so 5 goes and divides into 15 3 times. 5 will go into 5 1 time. That's all I can do. I also could have reduced the 2 5s if I wanted to. It wouldn't have made any difference. All right, so now we want to cross multiply. And when we cross multiply, I'm going to multiply the 1 here times the x minus 3. Now, 1 times x minus 3, anything times 1 is still going to be the same thing. I'm going to write it like this just so that you remember that if you don't have a 1 there, that you would have to distribute that value to both of those terms here. Here it doesn't mean very much because we're multiplying by 1. And then the other cross product would be the 5 times the 3. Okay. So we have x minus 3, 1 times x minus 3 equals 5 times 3. And now we're going to solve. So 1 times x minus 3 is still x minus 3 equals 15. And you want to add 3 to both sides. So x equals 18. And let's check our work and make sure we got it right. Okay. So now when we check it, we're going to plug it back into our proportion there and make sure that makes sense, that we have the same ratio. All right, so we're going to plug in not the 18, right? Because dm is x minus 3. Right? So we're going to plug in for the x minus 3. And EB is 5. And AD is 15. And AE is 5. Okay? All right, so x was 18. 18 minus 3 is 15. Well, 15 over 5, whether we reduce or don't reduce, certainly equals 15 over 5. Okay? Same ratio there. So we solved this one correct. Okay? All right, let's take a look at the next problem. So this one's a tricky problem. So make sure you watch this one real carefully and make sure you understand how to set this one up. The solving part, the cross multiplying and the solving for x, was the tricky part. It's the setting up. That's the part you want to be real careful on. All right, so we want to find the value of x here. And again, we have parallel lines, so our corresponding angles are congruent. And the shared angle using the reflexive property is also congruent. So that angle is congruent to itself. Angle BED is congruent to angle BCA, and angle BDE is congruent to angle BAC. Okay, so we have similar triangles here, and it's triangle BDE that's similar to triangle BAC. Again, you want to make sure you match up the correct parts. Okay? And it doesn't hurt, it's not a bad idea at all to just draw them separately so you can see the parts. So this is triangle BDE and this is triangle BAC. So this side is 4, 8. BA would be 4 plus 6 or 10. And then BC, this one is definitely a tricky one. It is 8 plus x. I think I'll even go over this one in class as well, because this is one students frequently make an error on. Not 8x, but 8 plus x. Just like we had to add the 4 plus 6, we have to add the 8 plus x. So let's set this one up in words first. Okay? And so the side I'm looking for is BC. I have a tendency to put whatever I'm looking for right in the first spot because I want to make sure I include that. So I'm going to use therefore measures, I'm going to switch colors, measures from triangle BAC in the numerator. So triangle BAC is going to be in the numerator and triangle BDE will be in the denominator. Okay, so BC corresponds with this side, corresponds with this side, corresponds with BE. And then we'll use the other two sides. BA corresponds with BD. So we have 10, or I'll put BD, excuse me. BD corresponds with, oops, excuse me, I put the wrong number there. BA. I forgot what the letters were. BA corresponds with BD. If I mix those up, it won't work out. BA corresponds with BD. So now we'll plug in the values. BC is 8 plus X. BE that goes with it is just the 8. BA is 4 plus 6, or 10. BD that goes with it is just 4. Okay? And we can reduce. I always like to reduce it. I think it makes things easier. We can reduce the 10 and 4. Both divisible by 2, so that would give us 5 and 2. And if you like, you can reduce in the numerator here. You can reduce the 2 and the 8, and that gives you 1 and 4, which makes this pretty easy in terms of your cross multiplying, because you've only got 1 times 8 plus x equals 4 times 5. I lost my 4 there. Right, so let's solve this out. So we have 1 times 8 plus x is 4 times 5. So 1 times 8 plus x is still 8 plus x equals 20. And then subtract 8 from both sides. X is 12. Okay? Which means that whole side would be 8 plus 12, or 20. So let's just double check and make sure it works out. Okay, so here's our check. We're going to plug the numbers back into our proportion there and make sure it works out. All right, so we have BC would be 8 plus x is 12 over 8 equals 10 over 4. So you notice that's just this right here. We want to make sure this still works out. All right, so 8 plus 12 is 20. So 20 over 8 equals 10 over 4. And 20 over 8 is reducible. Actually, they're both reducible. We can reduce 20 over 8. Those are divisible by 4. 20 divided by 4 is 5. 8 divided by 4 is 2. And then 10 and 4 are both divisible by 2. So 10 divided by 2 is 5. 4 divided by 2 is 2. Right, so that checks out. And the value of x there is 12. Okay? I hope this is making sense to you and you're finding this not too difficult. Because really, as long as you set them up correctly, the solving on these really isn't bad at all. All right, so we want to find the value of a and b. How can we find this? You might say, I'm not sure. However, I know that they're similar triangles. How do we know that they're similar triangles? Well, we know they're similar using angle here. So triangle R, and we don't have 3 letters, we just have just called triangle R, is similar to triangle S using angle similarity postulate. All right, so we have 2 angles. Actually, we have 3 angles of one triangle congruent to 3 angles of another triangle. These triangles are similar. All right, so when you match them up, make sure you match small with small, medium, large with large. Now, it's easy to figure that out in triangle R, which has all its values. Not so easy in triangle S, which has A's and B's in it. However, use your congruence markings to help you out. So 6 here is the small side. Notice that's between the 1 arc and the 2 arc angles. So who's between the 1 arc and 2 arc in the other triangle? Well, that's B. So B here is the small side. And so do you see how they're in between the same, that segment of the triangle is in between the same angle sizes. And we can tell because we can see they're marked with the congruence markings. So that tells us, the small side is on the side between the 1 congruence mark and the 2 congruence mark angle. All right, so let's find the medium side is over here between the 2 and the 3, And so who was between the 2 and the 3? Well, that's A. And then the large side is between the 1 and the 3. The 1 and the 3, that would be 6.4. Okay. Now, you cannot use A and B in the same proportion to solve because otherwise you have too many variables. So we have to use this one, the only side in triangle S where we know we have a number value. So we're going to have to match up the large side and the large side. Okay? So large is going to go together, and then we'll just solve for them. I guess we'll solve for them alphabetically. So that means we're going to have the medium sides. All right, so, and I think I'll put triangle S in the numerator and triangle R in the denominator. So the large side, triangle S, is 6.4. The large side in triangle R is 8. Equals. And then the medium side in triangle S is A. And the medium in triangle R is 7. Now you could reduce the 6.4 and the 8. You might notice, hey, 6.4, 64, maybe it has something to do with 8. I think on this one, I'm just going to cross multiply, okay? And then we can reduce afterwards. All right, so I have A times 8. So I have my one cross product. And actually, you know, I'm gonna do that in a separate color so it stands out. And maybe in a color that's not too dark. I'll do it purple. So one cross product, and here's the other. So we have 8 times A, 8A, equals 6.4 times 7. And 6.4 times 7, well, 6 times 7 is 42. And 4 times 7 is 28. So 0.4 times 7 should be 0.28. I'm just going to double check that so with a calculator here, which I have handy, just to make sure, because it is kind of late here. I've been here a while now. As you can tell from the clock that's on this recording. So 6.4 times, it's 44.8. So like I said, 42 plus 2.8. But I just wanted to make sure that I wasn't overthinking anything. Sometimes you can do that when you're tired. So we have 8A equals 44.8. We're going to divide both sides by 8. So A is 5.6. I kind of noticed that's 7 times 0.8. Just saying. So maybe we saw that relationship there. Okay, so now we found A, and let's find B. All right, so I'm going to do the same thing. We're going to have triangle S in the numerator and triangle R in the denominator because, well, why not? Make sure you use the large side again, and then you'll use the small side to find B. Don't use the side you found, because what if you made a mistake on A? Well, if A was incorrect and you use that to find B, B is going to be incorrect. At least you know for sure that 6.4 is the side in the triangle. So 6.4 goes with 8 again, and the 6.4, now we have B is the small side in triangle S, and that goes with 6, the small side in triangle R. I think I'm going to reduce in the denominator there. I'm going to make that decimal a little bit bigger too. I can reduce in the denominator. The 8 and 6 reduce. I could make that, they're both divisible by 4, by 2, so that would be 4 and 3. You don't have to. You could leave it just the way it is, or you could reduce. It really doesn't make that much of a difference. And really in this problem, it makes almost no difference at all. You know what, I think I may just not even bother with the reducing. But that's what you could do. Here, it really just doesn't make it much of a difference. And so we're going to cross multiply. Okay, so we're going to have 8b equals 6 times 6.4. And we'll multiply that. So 6 times 6 would be 36. And then 6 times 0.4 would be 2.4. So that should be 38.4. And then we just need to divide by 8. And if we divide both sides by 8, b is going to be, let's see if you can figure it out before I tell you. It's going to be 4.8. Now, interestingly, that's 0.8 times 6. So one thing you could have done, you could have reduced the 6.4 and the 8, and that would have been 1 and 0.8, but I chose not to. Okay, so here's how to find this problem. Really not bad, and it's actually not too hard to figure out how to set these up. Just make sure you match up the corresponding sides, and make sure you only solve for one variable at a time, and keep one triangle in the numerator and one triangle in the denominator. And I think this is where I'm going to stop this lesson. I think we'll look at this problem and the next one in class. So I'm going to stop right here. I hope you found this, I'll end with this picture here. I hope you found this tape informative and it all made sense to you. And I'll see you in class. Have a great weekend. Bye.